The Red Legacy. Episode 4. The Frozen Heart of Mars. Welcome back to The Red Legacy. Mars may look like a lifeless desert, but hidden beneath its silent red dust lies a secret so powerful that it could change the future of human exploration forever. It is a secret locked in ice, a frozen world beneath a barren one. Today we travel deep into the frozen heart of Mars, where water, ancient climates, and the possibility of life converge in one of the planet's most mysterious chapters. The story begins at the poles. From orbit, the Martian poles appear like vast shimmering crowns, broad caps of ice stretching across one of the coldest regions in the solar system. These caps are not made of a single type of ice. They are layered mixtures of dry ice, or frozen carbon dioxide, and water ice, stacked over millions of years like the rings of a cosmic tree. Every layer records a different season, a different era, a different climate cycle of Mars. In winter, temperatures here drop so low that even the thin Martian atmosphere freezes. Carbon dioxide falls like snow, settling on the surface in a soft white sheet. When summer returns, sunlight transforms the frozen carbon dioxide directly into gas again, releasing it into the atmosphere. This seasonal rhythm makes the Martian poles breathe, expanding and shrinking, inhaling and exhaling in cycles older than humanity itself. But beneath this seasonal dance lies something more enduring: massive reservoirs of water ice buried under dust and ancient sediments. Scientists estimate that if all the water ice at the poles melted, it could cover the entire planet under an ocean dozens of meters deep. An entire world's worth of lost water sleeping in plain sight. The polar ice caps are not the only places where ice hides. Across the mid-latitudes, ground-penetrating radar from orbiting spacecraft has revealed enormous frozen structures buried just a few meters below the soil. These glaciers stretch for tens of kilometers, preserved under layers of dust that protect them from the sun. They formed long ago during epochs when Mars had a thicker atmosphere and a different tilt. Times when snow fell across regions that are now bone-dried deserts. This buried ice is more than just a relic. It is the key to understanding the Martian past. Every inch of frozen water may contain trapped bubbles of ancient atmosphere, preserved minerals, or chemical fingerprints that hint at conditions from millions of years ago. They may even hold something more profound: evidence of microbial life that might have once flowed with the liquid water. As we move deeper into the Martian subsurface, we uncover ice that may have survived for billions of years. Ice that formed when rivers still carved valleys, when lakes filled craters, when Mars was warmer and wetter. This ancient cryosphere may be the last surviving archive of a once vibrant planet. And yet this frozen heart is not completely locked. Under certain conditions, even today, pockets of ice may melt briefly. Dark streaks on slopes, known as recurring slope lineae, suggest the possibility of briny liquid flowing for short periods. Though controversial, these features spark an exciting question. Could liquid water still exist on modern Mars, even if only for minutes or hours? If it does, it might support microbial life in extreme environments. The search for these possibilities drives missions like the Mars Reconnaissance Orbiter and Europe's ExoMars program. Their instruments scan the surface, probing for chemical traces, patterns in mineralogy, and temperature shifts that hint at underground ice. Every discovery adds a new piece to the puzzle, revealing a picture of Mars that is far more dynamic than once believed. For future human explorers, this ice is not just scientific treasure, it is survival. Frozen water could be melted for drinking, split into hydrogen and oxygen for fuel, or purified for long-term habitation. Understanding the distribution and purity of Martian ice is essential for building a sustainable presence on the red planet. The frozen reservoirs will act as the wells of a distant frontier. But extracting it will be a challenge. Martian ice is mixed with dust, locked in hard layers, and often buried beneath unforgiving terrain. Machines will need to drill, heat, and process the ice carefully. Habitats will require shielding from radiation and protection against storms. Yet the reward is immense. A future where humans live on Mars using the planet's own resources. Even now, scientists are modeling how these ancient glaciers formed and changed over time. By studying their patterns, we decode the rhythms of the Martian climate, how the tilt of the planet shifted, how its atmosphere thinned, how its water escaped to space. Each discovery brings us closer to understanding what Mars was and what it could one day become. The frozen heart of Mars is a testament to the planet's hidden potential. On a world that seems dry and empty, ice becomes a symbol of possibility. It carries the memory of ancient oceans. It shapes landscapes, feeds storms, and whispers about a time when Mars may have been vibrant. It offers hope that life might have once existed, or perhaps still does, hidden in cold, dark pockets beneath the ground. As we explore deeper and push farther, this frozen world will guide us toward life, toward discovery, and perhaps toward our future beyond Earth. Thank you for watching till the end. You were watching The Red Legacy.